In this demonstration, I'll use Deployment Manager to create a GCP deployment and maintain it. I'll also view resource usage in a virtual machine using Google Stackdriver. I'll work with Deployment Manager using Cloud Shell. For the sake of convenience, I'm going to define an environment variable containing my preferred GCP zone. I already have an environment variable containing my GCP project ID. Now I will create my Deployment Manager template using a text editor. I've created my template in another window and I'll paste it in here. Now let's take a look at what we have. This template defines a virtual machine as a resource. It's named MyVM. This virtual machine is defined to have a startup script, apt-get-update, which calls for its database of applications to be updated. Be aware that the syntax of Deployment Manager requires you to specify the preferred zone in a few places and the GCP project ID in a few places. We'll substitute them into this file using the sed command. I'll write my file out to disk. Now let's use sed to substitute in our project ID. The sed command has no output when it is successful. Similarly, we'll use the sed command to substitute in our preferred zone. Let's look at the file again and see our results. Our GCP zone has been substituted into the template, as has our GCP project ID. Now we're ready to build a deployment from this template. The template will create a new deployment in Compute Engine. It'll be called MyFirstDepl, and it'll use the template mydeploy.yaml. It's done. We can confirm its status using the gcloud command. There's our deployment, MyFirstDepl. Now let's look at the resulting virtual machine. We'll go to the Compute Engine VM Instances page. There's our virtual machine, my-VM. We click on its name to open its details and scroll down, and there's its startup script, apt-get-update. Now let's make a change to our template. I'm going to add a command to the startup script. This new command installs the Nginx Lite web server. Now we'll update our deployment. Now that the update is complete, let's go back to our virtual machine instance detail page and now look again at the startup script. The startup script has been updated. Now let's put some CPU load on the VM we created and monitor it using Stackdriver. First, we'll log into the virtual machine by connecting to it using SSH. This Linux command creates an artificial CPU load on the virtual machine. In essence, it forces the CPU to continuously attempt to compress random data. Now let's return to the GCP console and set up Stackdriver monitoring. In the Products and Services menu, we scroll down to Stackdriver Monitoring. We confirm that we want to create an account. And we'll confirm that we wish to monitor our GCP project. We don't want to monitor any AWS accounts, so we'll click Skip AWS Setup. For this particular activity, there's no need to install the Stackdriver monitoring agent, so we just click Continue. We don't need to get reports by email for this demonstration, so we click No Reports. Now we click Launch Monitoring. We'll click Continue with the trial. Notice that our CPU utilization increased sharply a few minutes ago when we started our artificial load. In this demonstration, I used two GCP services, Deployment Manager and Google Stackdriver. Using Deployment Manager, I created a deployment and I maintained it. Using Google Stackdriver, I viewed resource usage inside of a virtual machine.